Anyone's daily life can be compared to physics in different ways.
While watching our day together, you can see how physics is shown. Our examples show how easy it is to see the physics in our lives and help answer the key whys of physics by using these different situations.
Watching us do simple things like playing tennis, drive a car, or have a simple accident are all examples how physics and momentum play a role in our lives.
Now, sit and relax while we explain how easy it is to incorporate physics into what we did on Sunday to have fun.
Let's go play tennis.
All right, let's go. Pause. Before we start anything, remember these formulas.
Momentum equals mass times velocity or times force.
Without knowing these, understanding momentum is impossible.
Here you can see a serve and a tennis using both impulse and momentum by the interaction between the tennis ball and the tennis racket.
An example of a bad hit is when Kirby hits the ball and the momentum change in the ball, wanting to resist that change in motion and her swing, not able to create a good force or impulse on the tennis ball. So the tennis ball reacts by an undesirable end velocity, which would be the speed dropping and the direction of the ball is downward.
As we start to play, you can see examples of good hits and how the momentum of the ball changes easily, because both Summer and I don't hit the ball in the same direction or the same way. A good play in tennis is when the momentum of the ball is easily changed by the impulse of the rackets between both players. The cause of momentum changing is the impulse of rackets. When it hits the ball, this collision creates a change in momentum and velocity of the ball, which is an example of an elastic collision.
Both momentum and kinetic energy are conserved in an elastic collision, or tennis in this situation, because no energy is lost. Both the ball and the racket don't deform permanently, so no change occurs and energy is only transferred between the tennis racket, the ball, and the player.
Here's a close-up of the interaction between the tennis ball and the tennis racket. You can see how the momentum of the ball changes from the impulse acted upon it by the racket, and how the velocity of the ball is affected when hit by a player. Pause. With more force put on the ball, I had a harder time bouncing the ball because momentum was greater.
Compared to mine, where I put very little force and was able to control the ball's momentum easier.
The tennis ball is bouncing off the racket because the racket has more impulse than the ball.
Looking at how my tennis ball reacts with a controlled up and down movement because of how little impulse I am creating through the racket.
Momentum is conserved because the total momentum of the racket and the ball before and after the collision is the same, following the law of conservation of momentum.
Hey Kirby, let's go to McDonald's.
Yeah, I'm hungry. Let's go. Good game.
Good game. Kirby, watch out!
Boom!
This accident is a collision called inelastic because the car parked and Kirby's car do not bounce away from each other when they collide.
The kinetic energy, which is the energy of motion, is not conserved at all compared to us playing tennis. When energy is conserved and only transferred, it never changed.
Oh my god, Kirby, what you did?
My car's okay, but this one's not.
Oh my god.
At least the driver's not here, but I mean,
Kirby.
it could be worse.
Let's leave before they find out.
What we are about to do, which is run away after hitting another car, is wrong.
Do not try this at home. Thanks for watching. I hope you learned a lot about physics and momentum. While watching our video, you can see how physics is everywhere. You just have to look around.
We had fun making it with the help of my mom, who was the camera woman, and Mr. Bracco.
And that's the end of our physics video project. Thanks, guys!